Well, good afternoon. It's a privilege for me, humbled even, to be invited to be part of this symposium that they've put together. Thank you to MDARD and MDNR, to our Natural Resources Commission here in Michigan to have the vision and to provide some of the resources to the sponsors, to those, Kelly and Chad and all those people who are unnamed that put in lots of time and energy to make this happen. I think it speaks well for our state and the passion that people have for that. As I was thinking a little bit about what draws us together, there's some obvious things, right? Chronic wasting disease has drawn us together today, but I think it's probably deeper than that. If we certainly we have a passion for the resource. That's why you're here. We've come from different places, different states, agencies, research people. It's what has prompted us to pursue some of the questions in the research that you've seen today, or to try to better understand what's going on. We have this passion for the resource, and perhaps that's deer or elk specifically, but I think probably at least represented in this room, it's bigger than that. It's a passion for our natural resources. It's a recognition that we have a responsibility to manage our natural resources well, right? It's this recognition that maybe even bigger than a responsibility, that we have a desire to pass on the experiences, the opportunities that we've had with our natural resources to future generations. That may not be true of the general public out there, of the whole hunting public out there. This even came up a little bit today in our lunchtime conversation at the table I was at, but I think it's probably true for this room. We recognize that we have responsibility and even a desire to pass on that passion we have for the natural world to our kids. So I'm going to do something a little bit different. This talk's going to be different than the ones that you've heard so far today. How many in this room, and recognizing that there are some that have children that are grown in God, but how many in this room have children that are under the age of 18? If you just by a raise of hands. Okay, so keep your hands up for a minute for me. Just because I have a gift for special recipients. So how many of those, keep your hand up if your children are under the age of 10? Okay, how about under the age of 5? All right, 2. All right, we've got a few left. How about 1? I got to get us down to 2. Okay, John can put his hand down, but so Anna and somebody in the back, so John is my PhD student, so, and I know he already has this gift. I'm going to wrap this talk. Did you see Anna? And in the back, who is that in the back? Joe. Hey, Kelly, can you make sure they get that? I'm going to wrap this talk in a book, maybe. Some of you are familiar with this book, right? We're going on a bear hunt. This is a book that I read hundreds and hundreds of times to my daughters. They're past the age of reading this book, but we read it a lot. We're going on a bear hunt. We're going to catch a big one. What a beautiful day. We're not scared. That's how every page of the board book starts. There's a sense of adventure. They're headed out. But the facing page has them encountering challenges and difficulties and obstacles that they have to overcome. Grass. I can't remember the adjectives right now, but long, tall grass. And we can't go over it. We can't go under it. Oh no, we have to go through it. And that's this repeated story over and over, and there's the great sound effects as you read through the story as this book, swishy swashy through the grass, and then they have to splash and splosh across a river, and there's squelchy, squirchy mud that they move through. But obstacle after obstacle, we're going on a bear hunt. We're going to catch a big one. What a beautiful day. We're not scared. And then they face another obstacle, a snowstorm, a cave, and then they encounter this bear. And if you haven't read this book, you should just go buy it. It's okay if you don't have kids. but they're going on this bear hunt, and they can't go over or under. They have to go through. Eventually they encounter this bear, and as they're tiptoeing, it's a deep dark cave, and it's tiptoe as they go into the cave, and they encounter the bear, and then they get very scared, and they have to run back, and it's you can, if you have children, you have to read books with emotion like this, and so you have to go really quick through all the sound effects as they move back, and so they progress all the way backwards, back through all of those things they went through, the sounds. As they head back, run into their house, under the covers. They're never going on a bear hunt again. It's a book that I read so many times. I have parts of it memorized, and I suspect to the day I die, I will know those opening lines of "We're going on a bear hunt." So what is this book, "We're Going on a Bear Hunt," have anything at all to do with this topic that I've been asked to talk about? Why is applied research important when it comes to chronic wasting disease? Well, I think there's some pieces of there's this idea in this story where, and maybe I'm stretching this a little bit, but there's some work involved with making their way through or surviving a difficult situation or a scary situation, a challenging situation, and to move forward, they had to go through the things that they encountered. They couldn't go over, they couldn't go under, they had to go through. And those experiences are what allowed them to survive. If I imagine the bear wanted to eat them, my kids always imagined the bear was friendly and he just wanted to hang out. But allowed them to survive because they had been through these things. They understood how it worked and what they had to do to get through the forest and through the snowstorm and through the mud and through the river and back through the grass and back to their house. And those experiences allowed them to work through those things. And as I thought about this talk and what we might talk about and how we could have a little fun because it's late afternoon, that's pretty close to how I would characterize applied research. It's research that we conduct for a specific purpose, to inform how or when or where we would respond to a real world challenge. That's what applied research is. And I think it's really important for us as we think about chronic wasting disease, because chronic wasting disease has some really serious implications. There we go. You've heard these packaged in different ways today, but I want to remind us there are some very serious implications for chronic wasting disease, and they're bigger than just the deer resource. Certainly we have concerns about long-term impacts to deer populations from the deer resource. Dr. Fisher opened our session today, and a piece of that talk was studies that are being published that show 30 to 60% declines in deer populations after long-term higher prevalence levels. That's a big deal, and that's something that is drawing us together. Passion for our deer resource, but it's bigger than a passion for the deer resource, because in a state like Michigan, deer, licensed sales from deer, they fund a majority of the conservation programs in this state. And when you start to incorporate PR funds and the research dollars that come from that, a large majority, that's a little redundant, but a majority of conservation funding, at least in a state like Michigan and other states in the Midwest, is dependent on our deer resource. So a threat to the deer resource is a threat to our conservation programs more broadly, to non-game species, to habitat improvement, to things like that. We have to be taking this very seriously. And another thing that we've been talking about a little bit, and it came up some with Dr. Nichols' talk with plant uptake, there's some very real future concerns that some of us have for threats to the agricultural economy moving forward. If the prions move into crops that are being produced, whether that's a real threat or a perceived threat, there are some very serious consequences that could come from this disease. And so I think you've heard the seriousness of this disease as we move forward, but I wanted to be reminded of that. It has some wide-reaching potential implications for the way that we do things or have done things. So as I was preparing for this talk, I was thinking about, okay, well, what has applied research looked like through time? And so I did what any good professor would do. I tasked some of my graduate students with some work. I asked them to go in and do a literature review and help me understand what trends have looked like through time, for what contribution has applied research had to overall CWD research. And so they went through, and here's some of the broad categories. They reviewed about 400 papers for me, and I'll recognize them at the end, but they worked through this literature. And some of the broad categories that we had things in that I'm going to show you a temporal trend just is basic research. A lot of the things we've heard today I would categorize mostly as basic research. That doesn't mean it's not important. That's not a qualifier word. It's just saying that this is research that is foundational in our knowledge about the disease. And so here I have a paper pictured here by Beth Williams that characterizes chronic wasting disease in mule deer. That would be an example of a basic research paper. Applied research papers are ones that answered a specific question about a real world problem, and we probably could debate all day long on what those are. But a good example here is this Potapov paper that looks at how we might use transmission mechanisms and evaluate harvest strategies and harvest management possibilities with that. And then there's also a lot of papers out there that kind of review the current state of knowledge as we move forward. And so we looked at these categories of about 400 papers here, and this is what the trend looks like over time. So we have time on our x-axis from 75, so first accounting of chronic wasting disease in 1967, before we have this, and the number of publications on the y-axis. And so the yellow line represents basic papers. They dominate the literature. The blue line is the applied research. You can see that it's a smaller portion of the overall publications that are being put out there, and then reviews make up a smaller portion. Just to give us some context in the timeline, so 78 is, we have CWD classified as a TSE. We have the first wild elk positive in 81. So these are publications that are corresponding to that. Wild mule deer. We have captive cervids testing positive in Saskatchewan. We have white-tailed deer testing positive in 2001. And then we're really hitting this time when the research and the publications on that research is exploding. And one of the important things that I want us to see tied to that, and good, it shows up on your screen, not on my screen, is there was a influx of federal funding. Started in 2002, went to 2011. And that really drove a lot of research. You see that big jump in the number of research publications there. And I don't have any discomfort in saying that an influx of funding, of federal funding, was a big driver in that, as well as the more frequent encounters with the disease across the landscape and in different species. But one thing I think is important to note is that funding ended. And when we think about the state of Michigan and other states, perhaps we all know this, but they're tasked with funding their CW management today without that as a resource. And you can see that basic research has tanked as far as number of publications. I think that's a fair technical word, that it's tanked. But applied research has continued to improve. One of the things, as we looked at applied research here, we had it characterized fairly broadly, and as I started to think about this more, I had a conversation with Chet Stewart, who's the deer biologist for the state of Michigan, and I asked him, help me think a little bit more about the real levers that you have available to you to pull. Because if we're going to talk about applied research, we have to think about how does applied research actually inform real levers that can be pulled. And I think that challenges those of us who do research to think a little harder. And here are the responses that he gave me. And I think we could probably argue maybe a couple other ones if we start thinking about sharpshooters or things like that. But when it comes to the hunter harvest, we could change the number of hunters, and he wanted to make sure that I emphasized that he can change that in only the down direction. He could change what weapon types are available, season length, start date, the number of deer that are allowed to be harvested, and what sex could be harvested. And I think as researchers, this is a good reminder that the options that the agencies have to change harvest are pretty limited, and to think hard about how our research actually speaks to that, because there's often a disconnect between what we think is applied and what agencies think are applied. I said this talk is a little bit different, and what I wanted to emphasize, I think, is I spent some time thinking about, so what does applied research do for us? So I'm not going to give results of scientific studies, although I'll use some examples, but the examples are just that, they're examples. It's not for us to focus on what their results were, but I wanted us to think about why on earth would we value applied research? I think sometimes there's some pushback on conducting research associated with management, especially when it comes to something like white-tailed deer in Michigan. Don't we know everything there is to know about white-tailed deer in Michigan already? So the categories I kind of came up with as I thought about this are here are the things that I think applied research does for us. I think it allows us to explore management possibilities. I think it allows us to quantify the intuitive, and I'll expand on these each as we move forward. I think it causes us to challenge our intuition, things that we think we know about deer or deer populations or how they respond to management or disease. And also, I think a very practical thing that applied research does is allow us to focus our management efforts in time and space. So I want to go through a couple thoughts on some of these categories. So one of the big ways that applied research does for us is lets us explore possibilities. And I would say most of the time that the way that's played out is through simulations. We build models that simulate what populations do through time, how diseases might move through a population through time. We build models that simulate how animals might move across specific landscapes. And we use those models, which are informed by that really important foundation of basic research that's out there that we talked about before. And we can use them to evaluate different harvest scenarios, different sampling scenarios. And our ideal goal then would be to find some sort of management scenario that's robust to a lot of the different ideas we have about how the system works, that whatever the uncertainties are, and we've heard about a lot of those uncertainties, maybe it's density dependent, maybe it's frequency dependent, maybe it's this or that. We want to find management strategies that are robust to a wide range of possibilities. And so there's a lot of papers out there. One that I think does this well, and again, I don't want us to focus on the details or the specific numbers here, but this Alarida paper just from last year, one of the things that does and why I would characterize it as a good example of applied research is here they look at the potential outcome of different harvest rates for males and females, and according to their model, what might happen given those rates, and look at how that interacts with one another. So they have female harvest rate on the x-axis and male harvest rate on the y-axis. If you've seen this publication, I made it look a lot prettier for us today, but the same information is there, and it's the idea saying, hey, what combinations of harvest rates, this is a real lever that we could try to influence, what combination of those things might negatively impact the deer herd? That's extinction. That's a big orange area of that plot. What kind of combination of harvest rates for males and females might result in the disease persisting? We don't remove enough, we don't lower densities, or we don't reduce contact between individuals enough that the disease persists. And where might we find that sweet spot? I'm not suggesting this is the answer. This model is based on a density-dependent process, and Dr. Samuel just told us today that some of his work suggests that we should be thinking about this in a frequency-dependent. So I don't want us to focus on the numbers, but here's an example of research that's very applied, very specific, and tied to real management options that helps us evaluate or explore what the possibilities might be. Another thing that applied research does is let us quantify the intuitive. This is a frequent storyline that I have. It goes something like, we already know how deer behave. We already know what they do. Why do we need to do research? Why do we need to spend a bunch of money to study them or to put collars on them or do these things? And some of the work that we did in the state of New York in response to their chronic wasting disease outbreak, I suppose, or the few cases that they found, we looked at some of what can we learn from deer about their contact rates, their probabilities of contact through time and across space. And these are patterns that are really intuitive. Anyone in this room that's hunted deer or knows deer or studied deer, we all know that there are seasonal behaviors that deer go through. We know that there's time when, during fawning, when does isolate themselves, and we would expect low rates of contact. We know when the rut comes, they're interacting a lot. We would expect higher rates of contact. If we're in an area where they go into winter yards, we know that contact would be even higher in that time as they accumulate in real specific spots on the landscape. We know those things. That's an intuitive pattern. We also know that across space, animals that are far apart from each other are probably less likely to contact one another than animals that are close together on the landscape. Another intuitive relationship that we know. The difference is applied research, directed research at those questions lets us put numbers on that. So we could all say, yeah, we understand that, but then I could ask, okay, well, how much higher are contact rates during the rut than they are during post-parturition? How much higher are they in the winter? How fast do they drop off across the landscape? And that's where we need research to put real numbers on those things so that we can use that information for decision making. And that's what we did. And there's a paper out there that you can find on this, and I'll show you some of that. This is kind of a pretty picture here from that paper, but if we first think about seasonal dynamics for contact rates, so this x-axis here is the day of the year, and the z, the one going up, is this predicted probability of direct contacts. You see that cyclic pattern there as we move from the beginning of the year, day 0, January 1st, through the year. And in this population in New York, we have high contacts as they're together in the winter. That drops off as we head into the spring, starts to ramp up as we move into the fall. But now we have real numbers on that. We can even look at how that pattern changes as we have animals further and further and further apart on the landscape. And that's really deep, because then that allows us to start informing some spatial decisions for management. And we say, okay, well, how far out on the landscape do we need to consider, from a hypothetical positive case, the star in the middle, how far out do we need to go to account for 95% of the probable direct contacts that we might have, or 99%, or 50%, or whatever it is? We can start to put this probabilistic surface to our decision making and think about risk in quantified ways instead of just intuitive ways. We could also do the opposite. We could say, well, we have the resources and the means to manage this big of an area. What amount of the contacts are we going to hopefully include in that area, and is it even worth moving forward with that as an option? Another thing that applied research does for us is it allows us to challenge the intuitive. And I have another screen, but I don't have any information here because I wanted to pause and say this is fundamental to what science is. If I translate the word intuitive to hypothesis, this is what we do as scientists. This is what scientists are doing. A lot of times, I think the public says, well, the scientists are out to prove things. Typically, we're out to disprove things. That's kind of how we work. And so we develop ideas of how things work, but applied research either lets us quantify those patterns or challenge them or come up with other ideas. And there's lots of different things. Some that you've seen today. You saw some research about how hunter-harvest didn't change with high levels of targeted sharpshooting and calling in Illinois. And I think that's counterintuitive, especially to a hunter population that would say if you go in and you're doing a lot of targeted removal, it's not going to change it's going to reduce our opportunities for deer, and that didn't prove to be the case. Another thing I think is an interesting way to think about this is thinking about social structure of deer. One of the things Dr. Bill Porter, who I work very closely with, he and Nancy Matthews and others in the northern forest in New York established this evidence for social structure of deer there, and so you have these family groups, these mother-daughter matrilineal groups that form these social groups on the landscape that occupy distinct locations, and they even went in and said, okay, well, let's remove one of those groups and see how long it takes animals to move in. And the answer was, in that landscape, in that forest, it took about 5 years or so for deer, before deer moved in. And so one of the things we did when we, here in Michigan, we said, well, what if we could use that idea, something we think we understand about deer, we've demonstrated it in a different landscape, what if we could use that in a place like suburban deer management, where we have a lot of conflicting social opinions about what should be done about deer? What if we could go in and maybe they have these social groups well established in suburban areas because there's very little turnover in the population, not a lot of pressure. If we could go in and kind of surgically remove a social group from a neighborhood where we don't have as many competing opinions as we might in a whole county or a deer management unit or something like that, maybe we could use this in another location. And so we tested that. We went in, we didn't do the removal, but we went in and said, what do the social groups look like in these suburban areas in the same county as the first positive was found here in Michigan, in Meridian, the same township, Meridian Township. And so what we found is those social groups do exist, and they have clearly defined structure. The difference is they are stacked all over top of one another. So while we had this idea about how that might look based on another location, context really mattered. And I think that it's important for us to recognize that this is an important role that applied research has for us. It challenges the way we think things work. And then the last category I had here is that it allows us to focus our effort. Okay. One of the hardest things about doing deer management for disease or for other things is limited resources available. And so if applied research, this is an example of something we did in New York where we were trying to direct agency personnel in response to the 2 free-ranging cases that they did find, where should they go in and do more calls? And so we took things on resource selection for deer and probabilities of contact and information like that, and just developed a simple model that said, hey, we can direct you to focus efforts in some really high probability areas, and then you can start to work out the issues with landowner permission and things like that. That's a whole nother level of this. But I think so applied research lets us explore possibilities. It lets us quantify the intuitive. I think that's a big one. It lets us challenge the intuitive and focus our efforts. So I need to wrap up here. So I'm going to be a little bit of the optimist after following the last talk in a sense, but I'm not sure where we're at in Michigan. I think we're still figuring out where we're at in Michigan when it comes to chronic wasting disease, but how do we move forward? And I think, you know, as the panel is considering what we do, what recommendations we make moving forward, and as our commission is thinking hard about this, spending lots of energy on these kinds of decisions, I think it's important for us to be focused on finding diseased animals as early as we can, sharpening the focus of our removal actions, and then doing some field testing, because local landscape context really matters. That's demonstrated over and over and over in ecological processes, and validating this model. And I think the ways that we do that well is we invest in applied research. This is what I do, and so I'll confess I'm biased when it comes to this. This is what I'm passionate about, doing research that answers real questions that actually help us make decisions and make policy. But I think we need to be investing in applied research as a state and as an agency. I think we need to prioritize collaborations, and this is a good step towards that, but across states and across the regions. And then this last one's a bit jargony, but co-production of knowledge. We have a great model, I think, here in Michigan between the university and the DNR here. Very close relationship with agency scientists and university scientists. And why that is, well, that's built on building relationship and trust. But I think it's valuable because it allows us to stay focused on objectives that actually are useful to the agency. This is a constant complaint across the globe, probably, is university priorities and interests don't align with agency priorities and interests, and universities head off in their direction, asking the questions they're interested in, produce something that's just not useful to an agency. And I think that we need to really work together to co-produce this. And I would take that one step further. I'm talking, that's just universities and agencies, but I would take that also to the stakeholder groups. And that might function in ways like through structured decision-making workshops. I know that Commissioner Matonich was part of some of the turkey management groups where we have others that are coming in and saying, here are the levers that we think are really useful to learn more about. So I think we're already on our bear hunt. There are some serious implications. There are things that we're forced to go through. We can't go over them. We can't go under them. We have to go through them. And I think we have, in my optimistic way, at least in Michigan, a potential to respond well to these things. And I think we hopefully can say we're not scared. With that, I'll say thanks. Some acknowledgements are going to try to come up. There we go. Acknowledge the Resource Commission for motivating this, and my graduate students, Noel Thompson and John Cook, who did a lot of that, going through the research, the literature review of those papers, and then Sonia Christensen and Dr. Bill Porter, who helped lead some of the disease initiatives within the Quantitative Wildlife Center. So with that, I'll say thank you, and let us get to a break, I think.